All right. Hey guys, this is Mrs. Lyons, and today we are going to take a look at decomposition reactions. So in our last lesson, we talked about synthesis, which we said was the forming of compounds from two elements. So what we're going to do today is talk about the opposite, okay? So a decomposition, you know what decomposition is, things that die, decompose, they break down, okay? So in a decomposition reaction, a compound breaks down into simpler parts. The decomposition reactions we're going to talk about, we're only going to have compounds that break down into their elements. There are some that are more complex. So here's an example. A generic formula would be AB. So a compound AB reacts to form element A plus element B. Or you might have something more complex, like something with three elements in it, A, B, C, and these can break down into a compound and an element. Okay, the key thing to look at here is that we have one reactant and two or more products. Okay, we're going to stick to the simpler ones because they're more predictable for us. So an example is going to be something like potassium sulfide, K2S. That's going to break down into the elements potassium and sulfur. Okay? So, if we want to predict, all right, decomposition reactions, the first thing is that we determine that the reaction is a decomposition. And the way that we do that is that we only have one reactant, one compound. Okay. So once we see something as just one compound, we should think in our head, oh yeah, that's a decomposition reaction. Step 2 is determine what elements or ions the compound will break into. For us, it's going to be elements. Okay, we are going to identify the elements that make up the compound. Okay, so then what we're going to do next is we are going to write the states of matter and balance the chemical equation. All right, the states of matter of elements are on the periodic table. I'll spell it, periodic table. And basically, I talked about this briefly in the synthesis reactions, but there are only two liquids on the periodic table, and those are bromine and mercury. And then gases, there's not that many. We have hydrogen, nitrogen, oxygen, fluorine, chlorine. I'm forgetting something. Hold on. I have to peek at my periodic table. Nitrogen, oxygen, fluorine, chlorine. Nitrogen, oxygen, fluorine, chlorine, hydrogen, and then all of the noble gases. So like helium, krypton, argon, neon. Okay. These are designated on your periodic table, and they are also written in different colors on the periodic table on the wall in the classroom. Okay. But you do need to identify what state of matter each individual element is. All right. And then we want to look out for those diatomic elements. Remember Hoberfinkel, hydrogen, oxygen, bromine, fluorine, HRF, iodine, nitrogen, and chlorine. Okay, those are pure atoms that consist of two of the same, they're pure elements that consist of two atoms bonded together. Okay, so let's look at this reaction up here. We have aluminum sulfide. Okay, so the first thing that we're going to do is we're going to look and we're going to say this is going to break down to aluminum and sulfur. All right. So this is an ionic compound, so it is a solid. Aluminum is a metal. Sulfur is not in our list over here, so it's also going to be a solid. So all of those are solids. Okay. We've got states of matter. We need to double check, are any of these diatomic elements? They're not. So that means they just exist as individual atoms, no subscripts on the product side. So now we need to balance. All right. So over here on this side, we have 2 aluminum and we have 3 sulfur. Our subscripts tell us that. On this side, we have 1 aluminum and 1 sulfur. These are the sweetest reactions to do because I can just very simply go over here and put a 2 in front of the aluminum and a 3 in front of the sulfur. And now my equation, I'll put a 1 there, my equation is balanced. So pretty easy. I think decomposition, the biggest thing you'll see that people mix up on decomposition is catching those diatomic elements. Hopefully you will get better at this. All right, so here is another example. So we have sodium chloride. It's an ionic compound, so it's going to be a solid. It's going to break down into sodium and chlorine. Sodium is a metal, so it's a solid. Chlorine is a gas. Now, the other thing we got to think about is either one of these a diatomic element. I'm going to make my little list up here. H, O, Br, hydrogen, oxygen, bromine, iodine, nitrogen, chlorine. Oops, I forgot fluorine. Hoberfinkel. Hydrogen, oxygen, bromine, fluorine, iodine, nitrogen, chlorine. So chlorine is a diatomic element, so I need 2 of those. All right. Now I need to balance. So over here I have 1 sodium. I have 1 chlorine because there's no subscripts. That tells me there's 1. All right. Over here I have 1 sodium and 2 chlorine. All right. So in order to give me 2 chlorine over here, I have to put a 2 in front of the NaCl. Okay, that gives me 2 chlorine, but notice what else it does. It also gives me 2 sodium. Okay, so when you do a coefficient, you've got to put it out front and it will change things. So you kind of have to go back and forth. So here I have 2 sodium in the reactants, 1 sodium in the product. So I'm going to go ahead and put a 2 here, which now gives me 2 sodium, 2 chlorine on each side. So my equation is balanced. All right. Let's look at example 3. I have magnesium sulfide. It's an ionic compound. We've got a metal and a nonmetal. So that's a solid. Okay. It's going to break down into magnesium plus sulfur. Let's look. Magnesium and sulfur. Neither one of those is one of our 7 diatomic elements. So it's just going to be a single atom. Magnesium's a metal, so it's a solid. Sulfur is a nonmetal, but it's not in our list of gases or liquids, so it is also a solid. And this one's a sweet one too, because if you look, I've got 1 magnesium, 1 sulfur. Over here I've got 1 magnesium, 1 sulfur. So just 1s in front of each of those make that a balanced chemical decomposition reaction. All right, so I'd like you to pause the video and take a shot at number 4 and number 5. See if you can predict the products and balance. So pause the video for a minute and come back when you're done. All right, how'd you do? So let's go through these. So calcium nitride breaks down into calcium plus nitrogen. Nitrogen is a diatomic element, so it gets a 2. And then this is an ionic compound, metal and a nonmetal, so it's a solid. Calcium is a metal, it's a solid. Nitrogen is a gas. All right, now we need to balance. So over here I've got 3 calcium and 2 nitrogen. Over here I've got 1 calcium and 2 nitrogen. All right, so let's see. So my nitrogen are balanced already. My calcium is not balanced, but if I put a coefficient of 3 out here, now I'm going to put 1 here and 1 here. I have a balanced chemical equation. All right, last one before you have some homework to do. Aluminum bromide breaks down into aluminum plus bromine. Okay. Aluminum is not a diatomic element, but bromine is, so it gets a 2. All right. Aluminum bromide is ionic. That's a solid. Aluminum is a metal, so it's a solid. And then bromine is one of our 2 liquids on the periodic table. All right. All right, let's balance this bad boy. So we have 1 aluminum and 3 bromine. Over here, we have 1 aluminum and 2 bromine. All right. So this is one of those, and you'll get used to these as you see them and as you practice. When you see a 3 of one on one side and a 2 on the other, you're going to have to work to get them both to equal 6. So if I put a 2 out here, 2 times 3 gives me 6 bromine. It also gives me 2 aluminum. So we'll come back to that. Over here, I've got Br2. I need to put a 3 here. 3 times 2 gives me 6 bromine. All right. And so my bromine are balanced, but remember I added an aluminum over here, so I need to put a coefficient of 2 in there. So now I have a balanced chemical decomposition reaction. All right, so that is decomposition. I hope this video helps, and I will see you guys in class.